So now that we know about limits and continuity for vector valued functions, we can look at some problems related to that. So let's look at our first one. I want us to discuss the continuity of the vector valued function r of t, which will be ti plus aj plus a squared minus t squared k, where a is a constant, at t equals 0. So we're going to start by looking at the limit as t goes to 0 of our vector valued function. So when we take a limit, remember you take the limit and each component, ti plus the limit as t goes to 0 of a, j, plus the limit as t goes to 0 of a squared minus t squared k. Well, here I can just, these are polynomials, so I can just plug in t equals 0 to get 0i. A is just, that's just a constant, and so the limit would be a. And then plug in t equals 0, you'll get a squared k. And so in the end, the limit is aj plus a squared k. So the limit exists. Now, in order to be continuous, this needs to be equal to r of 0. So go back to your vector valued function up here and plug in t equals 0. And if you do, you'll get 0i plus aj plus a squared k. And you'll notice that these two things are the same. These are equal, which is what I needed in order to be able to say this function is continuous. So I can now say r is continuous at t equals 0. Because the limit existed and it was equal to evaluating my function at 0. So let's look at one more problem here relating to these. So let's determine the intervals on which the vector valued function and the function is going to be r of t is ti plus the square root of t plus 1j plus t squared plus 1k, so is continuous. So I want us to determine for which values of t is this function going to be continuous. So in order to answer this question, what we're going to do is we're going to look at the component functions. So what are our three component functions? F of t is t, g of t is square root of t plus 1, and h of t is t squared plus 1. Now if I look here, I notice that f and h are polynomials. Polynomials are continuous everywhere, and so I know that f and h are continuous on the interval negative infinity to infinity. So now the only thing I gotta look at now is g. Now g is a square root, And so the problem with square roots is we can't take square roots of negative numbers. And so g is not going to be continuous on that whole interval. It's only going to be continuous only for t needs to be greater than or equal to -1. You could also write that in an interval, -1 to infinity. And so if you put these kind of two pieces of information together, we get that r is continuous on the interval -1 to infinity. So you have to look at where these intervals overlapped. They only overlapped from -1 to infinity. And so r is only going to be continuous on -1 to infinity and not all real numbers.